Part 2, this is for questions 7 to 11. Question 7 is coming from integration. Part A, use the substitution u is equal to cos of x to show that the integral from 0 to pi sine 2x e to the power of 2 cos x with respect to x is equal to this one here, the integral from negative 1 to 1 of 2u e to the power of 2u du. Now, usually integration by substitution transforms what looks to be hard into a simpler version. So we are given u, which is equal to the cosine of x. That means the variable is changed. So we need to also find du, okay? Or we express dx in terms of du. So du dx here is going to be negative sine of x. So meaning that if you cross multiply here, dx shall be equal to negative du out of sine x. Then we need to also change the limits. So for for x, which is equal to 0, u will be equal to the cosine of 0, that is a 1. And then for x, which is equal to pi, u shall be equal to the cosine of pi, and that is a negative 1. Now, we come to this one here. We are having the integral from 0 to pi, then sine of 2x, then e to the power of 2 cos x with respect to x. Now this one is going to be the integral. 0 goes to a 1, and then pi goes to a negative 1. Then we have sine 2x. Using the double angle formula, we are going to have 2 sine x cos x, then times we have e to the power of, there is a 2 then cos x, but cos x is what? U. So we have 2u here. And then dx is negative du out of sine x. Now this sine x, we can see that it cancels with this one, not so? And then our cosine of x will be this u here. So meaning, I'm going to write integrate from 1 to negative 1, then 2u e to the power of 2u, and I will put a negative here, du. Now, it should be noted that when you integrate from a to b, f of x with respect to x, this one can be the same as minus, then b a, then f of x with respect to x. So when we switch these limits here, then we get a negative. Now, to absorb this negative that is in here, I will switch these ones here. So I will take this smaller one down, and then this bigger one up there. So that means we shall have the integral from 1 to, negative 1 to 1, then 2u e to the power of 2u du. Now this is a product of two functions. This is algebraic, this is exponential. So if we are to solve this one, then we are going to use integration by parts, okay? So this is what we are supposed to have. Then part B, hence find the exact value of this. Now already we have, this one has been transformed into the integral from negative 1 to 1, then 2u e to the power of 2u du. Now, this is a product of two functions. Like I said, we are supposed to use integration by parts, where one function is supposed to be differentiated, then another one integrated. How do we know which one to differentiate and which one to integrate? You use this acronym, ILET. I here is for inverse trigonometric functions, logarithmic functions for L, A is for algebraic functions, T is for trigonometric functions, E is for exponential functions. And based on what we are having here, this is algebraic. So we have algebraic function, and then here exponential. and also this one. So the one that comes before the other is the one you differentiate. So that means our u is going to be equal to this one here. Okay, now you cannot say u is equal to 2u. Okay, so what I'm going to say is we are going to differentiate, okay, this 2u with respect to u, we shall get a 2. Then our v, so dv dx, but now this one is in terms of u. Okay, so our v shall be the integral of this e to the power of u with respect to u. And you know, for exponential functions, when we integrate e to the power of f of x, what we do is to differentiate that power here, then we divide it in that exponential function like that. So what are we having here? We are going to differentiate this 2u, then we get a 2, then we divide it. So we shall have e to the power of 2u divided by 2. Okay, now that means our integral here shall be this integral from -1 to 1, then 2u e to the power of 2u du. This one will be equal to uv. So we shall get, this is our u, okay, 2u, then times v, which is this one here, okay, over 2, then minus, then the integral of v, which is this one here, times du dx. But here we are differentiating with respect to u, so we are having a 2 here, and then the u. Then we put the limits. We have our 1 and then -1. Now this one cancels with that, so we have u e to the power of 2u, then minus the integral. Of course, this one goes, so we have the integral of e to the power of 2u with respect to u. But just like before, here we are having this also. So we shall have u, then e to the power of 2u minus a half of e to the power of 2u. Then we put our limits, 1, -1. So put 1, we shall get 1, then times e to the power of 2, then minus a half, then times e to the power of 2. Then we subtract, put a -1, so negative of e to the power of -2 minus a half, then e to the power of -2. So here we have 1 minus a half. That one gives us a half. So we have a half of e to the power of 2. And then what do we have in here? We shall have, this is -1 minus a half. Then that one will be -3/2. But then it will be affected by the negative, so it becomes a plus. So 3 out of 2. Then of e to the power of -2. Okay, and I can stop there. They say the exact value, so don't put the value of e, just leave it there like that. Or you can write maybe a half out, then e squared, then plus 3 out of e squared. That one is always okay. Alternatively, we can use this synthetic approach. Okay, alternatively, this one can actually simplify your work. After identifying the two functions you're going to differentiate and then integrate, so you have here the sign, then the function to differentiate, and then the function to integrate. So from these two, we saw that this is the one to differentiate, this is the one to integrate. So you put 2u here, then the e to the power of 2u. So you differentiate this until it comes to 0. When you differentiate this with respect to u, you get a 2. Then differentiate it again, you get a 0. So you stop there because you have reached the 0. Then integrate this one. It is e to the power of 2u. And I think it is out of 2. So it's a half. Then e to the power of 2u. Then again integrate this. It will be now a quarter. Then e to the power of 2u. Because the 2, when you differentiate here and you divide it, so it is going to find that 2 there. Then it becomes this. Then now we multiply these ones diagonally like that. Okay, so multiply, but then the sign, of course, when we are integrating a positive function. Okay, here it is positive, so those ones, the signs, you just alternate them. So you have plus, minus, and then plus. So we start by going like that. So remember, when we are multiplying, we begin from the sign here, then you multiply there. The same thing here. Okay, so we also multiply here. Now that means the integral from -1 to 1, 2u e to the power of 2u du, then shall be, then this 2u times this, you have 2u times a half e to the power of 2u, then this negative times that, so we shall have that negative, then 2 times a quarter e to the power of 2u, then you put the limits 1 and -1. You're simplifying this, you will have this will be u, then e to the power of 2u, minus this will be a half e to the power of 2u, and then this is 1 and -1. If you can fall back here, I think this is exactly what we are having here. Not so? Yeah. That means I will just get whatever is here, and then I duplicate it, then take it down. And that is that. So that's how we do it using this synthetic approach. Question 8 is coming from differential equations. They are saying the variables x and y satisfy the differential equation, this one here, for f of x greater than 0. It is given that x is equal to 4 when y is equal to 2√3. Solve the differential equation to obtain the value of x when y is equal to 2. Now, the first thing we do when we are solving differential equations, we separate variables. So separating variables, and then after that we integrate and integrate. Okay. So what we are going to have is going to be to separate the variables, you put x on one side and then y on one side also. So we can just cross multiply. So this part here will go here, and then this one will go down, not so. Then this dx here will go up here. So meaning what we are going to have is dy, then here we shall have y plus 4, and then y squared plus 4. And then this side we are going to have dx out of x. You see that? That is separating variables, and that is one mark. Then we begin to integrate on both sides. Okay? Now, this one is y plus 4 out of this. So what I'm going to do is to split the numerator. So this one can be the same as saying y out of y squared plus 4 with respect to y. Then there is a plus here, then the 4, because these ones are going to be dealt with differently. Okay, when I differentiate 2y, I can get the y up there. Okay, so but then this is a constant, and this is y squared plus the 4, that will be arctan. So this one involves the natural log, this one involves the arctan. So we also come to this one here, 1 out of x, then with respect to x. So when we differentiate what is here, okay, we get 2y. Now if you integrate a function and you see that what you have in the numerator is the exact derivative of what you have in the denominator, then this implies that you are having the natural log of the denominator. You see that? Now when I differentiate this one, I'm going to get 2y. Then I ask myself, what should I do to the 2y in order to get the y here? I will divide it by 2, not so. So that operation I've done on this one here is what I'm going to multiply with the natural log of the denominator. Are we there? Maybe I can do this for you like this. When you differentiate this y squared plus 4 with respect to y, you're going to get 2y. Okay? 2y. But then I need to multiply it by half. So meaning I will put here, when I say a half of dy of this one here, the denominator, it's the one that is going to give me what is up there. Because first of all here, you are getting 2y. Remember, we don't have to change the meaning. So here we're having a y. So this is 2y. But now if I multiply with a half, I'll get the y. Not so? Which y is here? So what I'm having here is that when we differentiate the denominator and then we multiply it by 2, we get what is here. So you can take this a half outside, and then you can see that up here you are remaining with the derivative of what is down here. Is that so? So meaning we shall have this a half the natural log of the denominator, because what we have up here is the exact derivative of what is down, just like the way we are having this. Okay, but you don't need to do this or in the exam. Okay, so you just write. So from here I'll have a half, then the natural log. Okay, in fact, another thing that we are going to have, so let me write here a half. I think it will be here a half, then the natural log of y squared plus 4. Then we also have that if you integrate 1 out of a squared plus x squared with respect to x, this one gives you 1 over a. You can check this one here in the list of formulae, then the arctan of x out of a. Okay, then we can see y here is squared, then plus something here squared. This 4, I can take it here. That means here I'm going to have something like this. So plus, I can take the 4 here so that I create a 1 here. Then this is y squared. I can say the 4 is a 2 squared. So I can say 2 squared, then plus the y squared. But I'm integrating this with, of course, respect to y. But when you differentiate, of course, this x here, you are getting a 1. So this one is going to be the natural log of x. Then I can put the constant this side. Remember, you can put the constant on both sides. Okay, these constants are different. Maybe this is c2, this way we can get c1, but then you put them on one side, c2 maybe minus c1, you will get another constant. So better you put just one constant on one side. Okay, now here we shall get a half, then the natural log of y squared plus 4, then plus this is 4, and then here we shall have 1 out of, because this one is already in the same format as what we are having up here. So that is 1 out of 2 because our a is a 2, right? Then arctan of this will be y over 2, because here we have x over a, so it will be y over 2, like that, which is equal to the natural log of x, then plus c. This is the general solution of the differential equation before we find the value of c. Then using these initial conditions to get the value of c, what we shall come up with is what we call the particular solution. Okay, now we have x, which is equal to 4, and then y is equal to 2 root of 3. So we substitute here natural log of, this is 2 root of 3 squared, then plus the 4, then plus, of course, here we shall get a 2, then the arctan of y, this one is going to be 2 root of 3 over 2, and then this one will be natural log of 4, then plus c. So what will be the value of c? Here, when you square the 2, you get a 4, then times the 3, that will be a 12, then plus The 4, that would be 16. So we have a half, then natural log of 16, then plus 2, and then this one goes, so arctan of root of 3, that will be 60 degrees, but then we don't write 60 degrees here, okay? We write pi over 3, we write the angle in radians, so times pi over 3, then bring this on this side, we can have minus natural log of 4. Now, for this one, I can take this a half up here using rules of logarithms. So that is a half, then in fact, now that one becomes 16 power half is a 4, not so? Don't you think it cancels with this other one here? Because this is natural log of square root of 16 is a 4, then plus 2 pi over 3 minus the natural log of 4. So meaning that our c, the constant, is going to be 2 pi out of 3, like that. And then now we can get our particular solution as a half, then the natural log of y squared plus 4, then plus 2 arctan of y out of 2, and this one is equal to natural log of x, and then c is 2 pi over 3. So that is that. But then they said obtain the value of x when y is equal to 2. So if y is equal to 2, what is the value of x? So 2 squared will be 2 squared is going to be 4, then plus 4 you get 8, then plus 2, then the arctan of course this one will be 1, then we shall say minus 2 pi over 3, then this will be the natural log of what? Of x, and then we can say that this is a half, then the natural log of 8 plus this is 2 times, here we shall have pi over 4, arctan of 1, then minus 2 pi over 3, which is equal to the natural log of x. Okay, then what else do we have? And this one will be a half. In fact, I can take this one here and I have something like this. We have pi over 2 minus 2 pi over 3, then I can take this one up here, okay? So we have natural log of x, then minus the natural log of 8 power a half. So 90 minus 120, that will be negative 30 degrees. So that will be negative pi over 6 in radians. And then here we shall have natural log of 8, x out of the square root of what? Of 8. Also, then next, what do we do? Don't you think we eliminate this natural log? So you know that if you have log ab is equal to c, that means a power c is equal to what? To b, and the base here is an e, so e power this then is equal to what we are having here. So we have x out of the square root of 8, which shall be equal to e to the power of negative pi over 6, not so? Then you cross multiply. So suppose they had told us to get the exact value of x, then it would be root of 8, then e to the power of negative pi over 6. You see that? Well, this one you can write it as 2 root 2. Then since they just said the value, when you leave it here exact, it's okay. They can give you the max, or you can put it to 3 significant figures. So what would it be? Square root of 8, then e to the power of negative pi out of 6. We get 1.68. 1.68, that is to 3 significant figures, and that is that. Question 9 is coming from vectors. The lines L and M have these equations here. And then relative to the origin O, the position vector of the point P is this one here. But A, given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, and C. Okay, the position vector of P, which we can call OP, then is equal to 4I plus 7J minus the 2 of K. So if P lies on the line L, then it must satisfy the equation of the line L, okay? Let me even write that one there, like that. So the equation of this line L, okay, we are having R, which is equal to AI, then plus 3J, then plus B, K, then plus lambda, and then we have CI minus 2J, then plus 4K. Now I'm writing these I, J's, and K's with these waiver lines because for us we cannot write this bold, okay? It will look weird. So we always put the waiver lines under them. Now, we have here OP, the vector OP. Okay, this one is going to be, we have our 4I. In fact, what I'm going to do is to write this equation of this line L, okay, using the parametric one. I think using parametric equations. So I will have this R here, which is equal to I, we have A, then there is the C here, and then the lambda. So plus C lambda. And then the Y coordinate is going to be 3, then minus 2 lambda. So 3 minus 2 lambda. And then the Z coordinate will be B here, and then lambda times this 4. So plus 4 lambda. You see that? Now, this one will be equal to, in fact, let me put here my OP. Let me just put this one down here. Put this one here, and then that there. So we are going to have something like this here. Now we are going to equate, so they must have the same X coordinate, same Y coordinate, and same Z coordinate, okay? So I'll equate this one to 4, 7, and then negative 2, okay? So what do we have then? Let me in fact take this one away, just like that. So we have A plus C lambda is equal to 4. Then we have 3 minus 2 lambda, which is equal to 7. And then B plus 4 lambda is equal to negative 2. And I think from here, I can get the value of lambda. Then I substitute it here to get the value of B. Not so? So we have 3 minus 7, then will be equal to 2 lambda. This one will be a negative 4, which we shall divide by 2. And then lambda will be equal to negative 2. That means B here plus 4, then times negative 2 will give us negative 2. And then B shall be equal to negative 2. And this one here is negative 8, so when it crosses the equal signs, it becomes a positive. That means our B is going to be 6. You see that? Then we also have this value of lambda here. I can put it, I can also substitute here. So we can have A, then lambda, remember, is negative 2, so we have negative 2C, then is equal to 4. So this one I can keep it. Now, they also said here, given that L is perpendicular to M, So if L and M are perpendicular, then the scalar product of their directional vectors is always equal to 0. So we are going to have the directional vector of L dotted with the directional vector of M should be equal to 0. So the directional vector of L is this one here. So C negative 2, 4. We have C negative 2 and then 4. Then you dot it with the directional vector of M. That is what you see in brackets here. So that is 2, negative 3, 1. So you have 2, negative 3, and 1. So what do we have here? C times 2, of course that will be 2C. Then this times that will be a 6. And then 4 times 1, that will be a 4. Then this one is equal to 0. So this is 10. When it crosses the equal signs, it will be a negative. And then C becomes negative 1, 5. Not so? Now we come back to this equation here because we have gotten the value of C. So we shall have A minus, now 2 times negative 5. This one is equal to 4. This is A plus 10. Now that means when 10 comes this side, it will be a negative. 4 minus 10 is another negative 6. So therefore the value of A is negative 6, the value of B is 6, and the value of C is what? Negative 5. Part B, the perpendicular from P meets line M at Q. The point R lies on PQ extended with PQ to QR, which is equal to 2 to 3. Find the position vector of R. Now, I'm going to do something small here, a small illustration. I can have this line here, okay, perpendicular to, let's say, this other one here. So this one here is, let's say, line M. Line M. I'm just, I can draw these lines like this, whatever, okay? And I think maybe it is better that way, because when we just draw it horizontal, may not make much more sense. So let me just draw something like that, and also that. Maybe. So they are perpendicular. This is line M. Now where these two are meeting, they say that the perpendicular from P meets the line M. So this is the perpendicular, okay? Now from P, I'm going to put maybe my point P here. This is point P, but its coordinates, they were given here as, where are they? We have 4, 7, and negative 2. So we have 4, 7, negative 2, okay? Then it meets the line M at Q. That means Q is here. And then I said that if a point lies on the line, that means its coordinates must satisfy the equation of that line. So when we go to line M, this is what we are having here. Now, the x-coordinate of Q will be, okay, right from here, the x-coordinate of this line is going to be 1 here, then 2 mu. So I'll write here 1, then plus 2 mu. You see that? Then the y-coordinate is going to be 2 minus 3 mu. So 2 minus 3 mu. You see that? Then the z-coordinate is going to be 3, then plus a mu. So 3 plus a mu here. You see that? Then they are saying that PQ is extended. So we are extending this line like that with PQ to QR 2 to 3. So I'm going to say maybe our R is here. So this is PQ is 2, then 3. I will put my numbers there like that. Now, PQ is perpendicular. You can see that this vector PQ is perpendicular to the directional vector of this line M. Okay, because this one is maybe moving like that, so we shall have its directional vector moving that way, you see. So I'll say PQ is perpendicular, and for perpendicular vectors we find the dot product and we equate it to 0, not so? So PQ is perpendicular to the directional vector of M. So therefore PQ dot it with dm, then will give us a 0. How do we get PQ? PQ shall be equal to, you get OQ, you get the last minus the first, not so? So our OQ is 1 plus 2 mu, then 2 minus 3 mu, and then 3 plus mu. Then we subtract, we have OP, which is 4, 7, negative 2. And then we shall have 1 minus 4, that will be a negative 3. So we get negative 3 plus 2 mu. Then 2 minus 7 is another negative 5. So negative 5 minus 3 mu. And then 3 minus minus 2, that one becomes a positive 5. Then plus the mu. Okay? Then after that, and I think we can shift this one here like that. Then PQ here dotted with dm is equal to 0. So our PQ is this negative 3 plus 2 mu, then minus 5 minus 3 mu, and then 5 plus mu. We dot it with the directional vector of M, which we have as 2, negative 3, 1. So 2, negative 3, 1. Then we get a 0. Now this one will help us to get the value of mu. When we get the value of mu, then we can use this ratio here to find the value of R. Okay? So let's go. Not the value of R, but the position vector of R. Now when we multiply here, we shall get negative 6, then plus 4 mu, and then here negative 5 times negative 3, that will be a positive 15, and then this times that will be a positive 9. Then here we have 5 plus mu, which will be equal to 0. So this is 4, and I think there is something missing here. Here we must have a mu. Okay, like that. So that is better. Then we can have 4 plus 9, that is 13, then plus 1, that one will be 14 mu, and then this one will be equal to, so this is minus 6 plus this, I think that will be a positive 9, 9 plus 5, that is a positive 14, but then when it crosses the equal signs, it will be a negative 14. So meaning mu shall be equal to negative what? 1. Then after getting mean as that, then we can now find the coordinates of Q. Okay, coordinates of Q are going to be, put negative 1 here. You will have 1, then plus 2 times negative 1, then you have 2 minus 3, then negative 1, and then 3 minus 1. So what do we have? 1 minus 2, you get a negative 1. Then this one here is 3, then plus the 2, that one gives us a 5, and then 3 minus 2, that is a 2. Okay, then next, we can have this ratio here. They said PQ over QR is equal to 2 out of 3. So PQ out of QR is equal to 2 out of 3. Not so? Now I can even use vectors the same. So the length and the vectors, they are going to be the same. So meaning PQ is going to be 2 over 3 of QR. You see that? Then you can have 3 over 2 of PQ. Then will be equal to QR. Now for PQ, already we have it here. We can just substitute. Are we there? Then QR is the same as OR minus OQ. Like I said, you get the last minus the first. Then this one will be equal to 3 out of 2 of PQ. So we shall have 3 out of 2 of PQ. Then bring the OQ this side. So you add OQ, then this one will give you the OR. Not so? Now, what else can we do here is to simplify. So our OR is therefore going to be equal to 3 out of 2. Then, our PQ is here. So you have negative 3 minus, no, it will be a plus 2, then times negative 1, and then minus 5 minus 3 times negative 1. Then we have 5, then minus 1, okay? Then plus, I think here we are having OQ, yes, plus OQ, but our OQ, already we got the coordinates here, so that will be negative 1, then 5, then 2. Can't we simplify this? Of course. Now this one is 3 over 2. What do we have inside here? This is negative 3 minus 2. That will be negative 5. Then minus 5 plus 3. I think that one will be a minus 2. Not so? Then what else do we have? 5 minus 1. That one will be a 4. Then plus negative 1, 5, and then 2. Now going further to simplify this, it will be negative 15 over 2 when you multiply here. Then you add a negative 1. Then here times this. That one will give us a negative 3. Not so? Because the 2 will cancel with that. Negative 3, then plus the 5. And then this times this, so the 2 will go into the 4 2 times, then 2 times the 3, you will get a 6, then plus this 2, like that. So altogether, our OR is going to be 2 times negative 2. I mean negative 1, you get negative 2 minus 15, so that becomes negative 17 over 2. I can say that is I. Then this one, 5 minus 3, that is 2J. And then here you have 8. So you can have 8K. And this becomes our final answer. Or you can write it as a column vector. When you simplify here, no problem. They are all correct. Question 10. Here I'm seeing partial fractions. So we are saying that let f of x be this, and then part A we express f of x in partial fractions. If they give you part A as partial fractions, then the next part can come from binomial expansions or integration. So we have this 21 minus 8x, then minus 2x squared. But before you express this function here in partial fractions, always look at the degree of the numerator and that of the denominator first. So the degree, that is the highest power of x. So this one is a 2. And then here we shall have an x squared that comes from this, but then times the x, so that one will be x power 3. So that means the degree of the denominator is a 3. Now, if the degree of the numerator is less than the degree of the denominator, well and good. You can proceed with your partial fractions. But if you find that the degree of the numerator is greater or equal to the degree of the denominator, then you first long divide. That is an improper fraction, okay? So you need to first long divide. But here we just continue. So we shall have, this is 1 plus 2x, and then here this is 3 minus x, then to the power of 2. Now, we have a linear factor in the denominator, so that is a out of 1 plus 2x, then plus, this one is linear repeated, so we shall have b here. We take this 3 here, minus x when it is not squared, then c out of this 3 minus x, then squared. It's just like you can have 1 out of 2, then plus 1 out of 4. When you are finding the LCM here, you're going to use a 4. But remember that this one here is the same as 1 out of 2, then plus 1 out of 2 squared. Not so? Just like here. So when I'm solving these two, or these ones here, I'll take this as my LCM, because the 2 goes into the square. Not so? Then I proceed. So that is why when we are splitting this, we first use this one that is not squared, then we take this, which is squared afterwards. Is that clear? All right. Then this one is going to be our LCM, because of course when you are dealing with fractions, you need to get the common denominator. So the common denominator is going to be this one. You don't need to get this times this, then again times this one here. Already this one fits into this. So that means we are going to use, from these two, we only use this one, then times this to give us the common one denominator. So in other words, you are having this one as the common denominator. So divide by this, that means this one will cancel with this, and then you remain with this part. Then you multiply it with a. So that means we shall have a, then times what? 3 minus x, then to the power of 2, then plus, again get this one, divide by this, so that means this one will cancel with 1 here, then we remain with this times this, then we also multiply it with the b there. So meaning we shall have b here multiplying with 1 plus 2x, then also 3 minus x, and then this one here, divide by this one will cancel with this, we remain with 1 plus 2x, which we shall multiply with the c there. Meaning we shall have c times 1 plus 2 of x. Now this one will be equal to this numerator here. Okay, let me just copy it to save the time. We have that. Why are we doing so? It's because I can say divide by, then this one here, remember it is their common denominator, so I can put it here, but it is the same this other side. So we have something like that. So this is our fraction we have this way, which is equal to that. Now they have the same common denominator, so this and this will go. Do you see that the numerator here will be equal to that? So that's why after doing whatever we have done here, then we equate to the numerator. Now you find the values of a, b, and c. That is the task. Okay, how do we do so? Find the values of x that you can substitute in here such that some terms are terminated and then you remain with others. For example, if I let my x to be equal to 3, that means this term here is going to go. This term here will also go. That means I will remain with this one here. You see that? So I will be in position to get the value of c. Now, what do we have here? 3 times 2, that is a 6, then plus 1, that will be a 7. So you just write 7c, which is equal to, come to this side, you are going to have 3 squared, that is a 9 times 2, that is 18. So 21 minus 18, that one will give us a 3. Then put a 3 here, that will be 24. So 3 minus 24, you'll get negative 21. So I'll put negative 21 on the right side. And of course, when you divide all through by 7, what do you get? You get a negative 3. So your C is going to be a negative 3. Then we also look out for the next x value that can terminate one of the terms. Of course, I just get this one here and I equate it to 0. That means my x will be negative a half. So I say if x is equal to negative a half, this one will disappear, this one will disappear, and then I will have this one here. Okay, so we have 3 minus a half. What do you get? You get 2.5, which is 5 over 9. No, that's not that. Pardon me here. This one is a negative, so when I put it here, it is going to add up. So we shall have 3.5. So 3.5 is the same as 7 out of 2. When I square this one, it will be 49 out of what? 4. Not so? So here we shall have 49 out of 4 of A, which is equal to, then we substitute here, 21 minus 8, then times negative 0.5, then minus 2, then times negative 0.5. No, this one has to be squared here. So we get 49 out of 2. 49 out of 2. Now, from here, of course, the 49 goes, then you bring the 4 here. So 4 over 2, what do you get? Isn't that a 2? So that means our A is equal to 2. Then, the values of x that I can substitute in here to terminate some of the terms are done. So you can use any other value of x you want. And of course, the simplest one I can use is 0. So if x is equal to 0, that means here you have 3 squared, which is 9a. Not so? 9a. And then 0 here. So we have 3 times 1, that is 3, then times b. So we shall have 3b. Very good. Then we go to this one here. We shall have c plus c, which is equal to these two terms disappear. Then we have a 21. Now, what are we looking for? B. So B will be equal to this 21 minus your C, which is a negative 3. So minus that minus 3 of your B. Or I can say 21 minus C minus 9A. Then we shall divide by 3 because it is the coefficient of B. Now, B is going to be 21. The negative of the C will be positive 3. So plus the 3. Then minus 9 times 2, that is 18, and divide by 3. So what will be the value of B here? This is 24 minus 18, that will be 6, then divide by 3, you get a 2. So this therefore implies that our f of x is then going to be our A, which is 2, then out of 1 plus 2x. Is that clear? Then B is also a 2, then out of 3 minus x. And then our C is a negative 3 out of 3 minus x. But then this one is squared. Okay? And this is it. Now, part B, you can see that it is coming from binomial expansions. Hence, obtain. Hence means begin from where you have stopped. Obtain the expression of f of x in ascending powers of x up to and including the term in x squared. Now, we have our f of x, which is equal to, remember our A, we got it as 2, then over 1 plus 2x. So I can say this is 2 into 1 plus 2x. Using rules of indices, this one will become power negative 1, then plus again 2, then 3 minus x to the power of negative 1. And then I think we have, is it minus 3? Yes, minus 3. Then 3 minus x to the power of negative 2. Using binomial expansions, we know that a plus b to the power of n, when we are expanding, we shall get our two terms. So we have this a, we power it with this n, so a power n, then b power 0, then out of 0 factorial. The power of the b is the one that comes into the factorial here. And then the powers of b keep on reducing by 1, and then the powers of, the powers of a keep on reducing by 1, then the powers of b keep on increasing by 1. So how do we get the next terms? You'll be like differentiating with respect to a. So drop this power here. You'll have n, then a, and then power negative 1. You see that? Then b picks that power. This one loses the power, this one picks it. Then out of the power that is here is the one that goes into the factorial. Then again drop this one here. We can have n, then into n minus 1, then a power n minus 2, and then b power 2, then out of 2 factorial. Then you continue like that. Now we have this one here. It is 1 plus 2 x then to the power of negative 1. So we shall have a 1 here, power negative 1, then 2x here to the power of 0, then out of 0 factorial, plus we drop the power. So we shall have negative 1, then 1 here will be negative 1 minus 1, that will be negative 2. Then 2x now to the power of a 1, then out of 1 factorial. Remember, when you add these powers here, you always get this n that is given there, okay? Then plus, drop down this power. You have negative 1, then times negative 2, and then 1, the power here reduces by 1, so it becomes negative 3. And then here we have 2x, then to the power of 2, then out of 2 factorial. And then this one continues, but we shall stop here because they said up to and including the term in x squared. So this one will result in an x squared. We ignore the higher powers. Now here, of course, we shall get 1. 1 power n number is going to be a 1. Of course, power 0, this one is a 1. 0 factorial is also 1 because there is one way of arranging an empty set, okay? Then we have here, it's negative 1, then times the 2. Don't we get negative 2? So we shall get negative 2 of x. And then here, this one gives us a positive 2, which will cancel with this 2 factorial. And then here, we are having 2 squared, which is a 4. So we shall have plus 4, then x what? Squared. You see that? Plus the rest of the terms. Then we also go to 3 minus x, then to the power of negative 1. Now here we shall have 3, then power negative 1. Some people do this. They take away the 3 here, then they have 1, then minus x over 3, like that. And then they have 3 power negative 1, then times. So expanding this one here becomes easier for them, but me, I do everything all at once, okay? I don't want that. So what we can do, you put the power on the 3, that negative 1, then here the term is negative x. Please take it with its sign. Many people mess up here. The sign here, take it along with the term. Then 0 out of 0 factorial, then plus, drop this power, we shall have negative 1, then 3 power, this will be negative 2, then negative x here, power now 1 out of 1 factorial, then drop this 2 down here, so we shall have negative 1 times negative 2, then we have a 3 here, now will be power negative 3, and then negative x here will be squared, then you divide by 2 factorial. Do you see that negative 3 plus 2 will also give you negative 1, just as these ones added. So what else do we have? Now we simplify this. This one will be a third, 1 out of 3, not so? Then here we shall have 1 over 9 because it is 1 over 3 squared, not so? Then we can see that there is a negative here times a negative, that one becomes a positive. So we have positive 1 over 9, okay, of x. And then this one, of course, is going to cancel with this. Are we there? Then the square of a negative is a positive. So this is a positive and then a positive. So here we shall have a positive. And then 3 power negative 3 is the same as 1 over 3 cubed. And 3 cubed is a 27. So meaning we shall have 1 out of 27, then x to the power of 2, plus whatever is coming forth. Now our f of x, okay, our f of x, which is this one here, like that. So I will say this one is going to be equal to 2 into this expansion here. I think this is what we are having here. And better, I think I can write this like that. So we have 1 minus 2x, then plus 4x squared, plus whatever is coming forth, then plus 2 into, I think there is something missing. Okay, let us continue. So let me just leave this one here like that. We need 3 minus x, then power negative 2. I think it is here. We need the expansion here. Pardon me there. Now we proceed. This one is going to be, so you get your 3, then power negative 2, then negative x here, power 0 out of 0 factorial, then plus, drop this power. So we shall have negative 2, then 3. Now this one will be power negative 3, then negative x, then to the power of 1 out of 1 factorial, then plus. Now drop this. You will get negative 2. Okay, let me write it like this. Negative 2 times the negative 3. Then you have a 3 here, power negative 4. Then negative x here to the power of 2. And then you divide by 2 factorial, and then the rest come forth. Then this one will be 1 out of 9. Okay, then plus, of course, a negative times a negative, that's a positive. So this is 1 over 27, then times the 2. So we shall have 2 out of 27, and then times the x. And then here we are having this one as a positive, and also this one as a positive, not so? But these 2 will cancel with that. Then we have 3 here times, I think this one is going to be out of 3 power 4. Then we shall get 1 over 3 power 3, which will be a 27. Not so? Or you can put everything in a calculator, no problem. So plus, this one will be 1 out of 27 of x to the power of 2, like that. Now, the second one was this one here, so we put 1 over 3 here, then plus 1 over 9 of x, then plus 1 over 27 of x squared, plus whatever is coming forth. But then we have the third one here. There is minus 3. Okay, so minus 3, then times, this is 1 over 9 we have just gotten, then 2 out of 27 of x, and then plus 1 out of 27. Now we need to put all of these terms together and then simplify. So what are we going to do? Let us get the constants. Okay, this is 2, we will multiply with a 1, so that will be a 2. Are we there? Then this 2 will multiply with a third, so we shall have 2 out of 3. Then this minus 3 will multiply with with 1 over 9. So you'll get, that one will give us negative 1 over 3. So that is the constant part. Then the part that has gotten x is this one, 2 times negative 2 here, which will be a negative 4. Then 2 times this 1 over 9, that will be 2 out of 9. And then minus 3 times this one here. Don't you think you are going to get, this is 2 over 27 times the 3. This one goes here 9 times. So it's going to be 2 over 9, but with a negative. Not so. So minus 2 over 9. But all of these ones have gotten x on them. The next, for x squared, we have 2 times the 4. Isn't that an 8? Yes. Then 2 times this one here. That will be 2 out of 27. And then 3. And then this, so that will be negative 1 over 9. Then x squared. The rest you ignore. Now, our f of x simplified is going to be, of course, this one will be a third. So 2 plus a third, this times this is 6, then plus 1, that will be 7. So here we shall have 7 out of 3. Then what do we have in here? Of course, this one goes. Then we have minus 4x. Not so? Minus 4 of x. Then next, we go to this one here. 8 plus 2 out of 27. Then minus 1 out of 9. This one gives us 215 out of 27. 215. 215 out of 27 of x squared, because you ignore higher powers, and that is that. Question 11 is coming from complex numbers. The complex number z is defined by z is equal to this, where a is an integer. An integer is a positive or negative whole number. It is given that the argument of z is negative pi over 4. But a find the value of a, and hence express z in the form x plus iy, where x and y are real. Now, our z is 5a minus 2i out of 3, then plus ai. This one, we can rationalize the denominator or realize the denominator. So you get the conjugate of the denominator, you multiply it in the numerator and the denominator. So what's the conjugate of a complex number? You just change the sign of the imaginary part. So what we do down here is what we do up here. So it's like we have done nothing, okay? It's like we have done nothing, because this one can easily cancel with that, okay? Now, we simplify this one. So 5a times 3, that one will give us 15a. And then 5a times negative ai, that one will be negative 5, then a squared I, not so? Then negative 2i times 3, I think that will be minus 6i, not so? But we should know that in complex numbers, I squared is always equal to negative 1. Now, minus 2i times ai, that one will give us positive 2a I squared. But I squared is negative 1, so we shall have negative 2a. Then we divide by, here, this is the difference of two squares. So, but if you don't want, you can still do this one, and then you continue. You can expand it like the way we did up here. 3 times 3, that one is a 9. But me, I don't want to waste that time. You just say 3 squared. It's a difference of two squares. Then you get your ai. You also square that. Now, up here we have 15a minus 2a. What do we get? Isn't that a 13? 13a. Then we can say minus, a negative is common here. So I can say minus, that would be 5a squared plus 6 of I, not so? Then we divide by, this will be 9 here, then plus a. Because remember, I squared is negative 1, so it is going to affect that negative. You see that? And we must have a square there. So meaning our z is going to be equal to, I can write it in this format, x plus iy. So the real part is going to be this 13a, then we divide by this denominator here, which is, I can write it as a squared, then plus 9, or 9 plus a squared, whatever. Then the imaginary part is this one here, so I put minus, then this is 5a squared plus 6, then we divide by a squared plus 9, this one here, then I. You see that? Now, they said here that the argument is a negative. So that means this one, the complex number here, must be here in the fourth quadrant. Remember, before finding the argument of a complex number, you need to identify the quadrant within which it lies. Okay? Now, here we have something like that. So this one here is the negative pi over 4. Okay? So our z is there. So what are we going to have? Now, argument of z, remember, if you have, this is your x, and then this is your y, so the angle that is here, you're going to have tan of theta is equal to the opposite over the adjacent. So meaning, this argument is going to be the arctan of the imaginary part over the real part, okay? So I can say argument of z is equal to the arctan. Right from here, the imaginary part is this, which is 5a squared plus 6 out of a squared plus 9. Then we divide by this one here, which is 13a out of a squared plus what? 9. Not so? I think better I can write this like this, out of a squared plus 9, like that. Now, argument of z is given as negative a quarter. So we can put negative a quarter here, then which is equal to the arctan of, now we have the negative of this 5a squared plus 6 out of a squared plus 9, then times the reciprocal of this one here. So we have the a squared plus 9, then out of 13a. Don't you think this one is going to cancel with that? So we shall have, of course, you take the tan this side. Now you'll have tan of negative pi over 4. Then this way we shall have negative 5a squared plus 6, then out of 13a, like that. And this one here is negative 1. So negative 1 is equal to 5a squared plus the 6 out of 13 of a. So there is also negative here, which cancels. Not so. There's a negative here, but it is going to cancel with this one here. So meaning when we cross multiply, we can have 13a, which is equal to 5a squared plus the 6. Then take this on this side to form a quadratic in a. We shall have 5a squared minus 13a plus 6, which is equal to 0. Then we can solve this quadratic. Let's see whether this one is factorizable. Mod, then equation is 5, then quadratic is 3, and we have 5, negative 13, and then 6. So we get 2 and then 3 over 5. So I will skip some space, and then I write a is equal to 3 over 5, and then a is equal to 2. We need to get the factors from which these roots come. There is always a mark for attempting to solve the quadratic equation. So cross multiply here, you get 5a. Then bring this one here, you get minus 3. And then bring this one here, you will get a minus 2. So by doing that, we have already cheated the examiner. This is the attempt to solve the quadratic equation. Here we have used what? Factorization. If you want, you can use the quadratic formula, no problem. But they said that a, for a being an integer, we are supposed to take the whole number. So therefore, a is equal to 2. Is that clear? What did they want us to find? So find the value of a, and hence express z in that format. Now go back up here. Our z is this one. So therefore, z is going to be 13 times 2 out of, we are going to have 2 squared plus 9. Then minus, we have 5 times, this one looks like 6, so 5 times 2 squared, then plus 6 out of 2 squared plus 9, like that. So simplified, our z is going to be, this one is 26, this is 13. So if there's a 13, that 13 will cancel with that, then we get a 2. So that will be 2. Then, of course, this one is going to be 4 times 5, that is 20, and that will be 26, then divide by 13, that one is also 2. So we have minus, then 2i, and that is that. Part B, express z cubed in the form r e power I theta, where r is greater than 0, and theta ranges from negative pi to positive pi. Give the simplified exact values of r and theta. So here we are expressing it in the exponential form. So r is equal to the modulus of z. Now this one will be equal to so I'm going to first find z in terms of, in this format, then after I cube it, okay? So remember our z, okay? We have z as 2 minus 2i. So its modulus will be 2 squared, then plus negative 2 squared. This is 4, then plus 4. That will be 8. So root of 8. Yes, that is the one. Let me just leave it there. I'm not going to simplify it. But still we can do, because there is cubing. So this is the same as 2 root of 2. Okay. Then the argument of z, we know that it is negative pi over 4. It was given. So argument of z is negative, and that is the theta. Negative pi over 4. Actually, let me take this one off. Now, when it comes to, so this simply implies that our z is going to be 2 root of 2, then e to the power of negative pi over 4 of I. Now, when we say z cubed, we get whatever is this side, and then we cube it. Okay? So you cube everything here. Now, when we cube this one, it is the same as saying 2 root 2 times 2 root 2 times 2 root 2. Then here for the part of e, using the rules of indices, if you have a power b, then power c, then you are going to have a power b times c. That means here I'll have negative pi over 4, so I'll multiply it with that 3, then you have that one there. And what do we have? I here. Okay. This one is 45 times 3, that is 135. So if it's a negative, that means we are here. This is 90. So actually you're having a 45 here, then another 45 here. So that means z cubed will be lying in the third quadrant here. So its argument is this negative 3 pi over 4. Okay. That's what it means. All right. Now we can proceed here to simplify. Our z cubed is going to be 2 times 2 times 2. That one will give us 8. Now, root 2 times root 2, that one will give us a 2. Then we remain with the root 2. So 8 times 2, that is 16. Then root of 2. So we shall have 16 root 2. Then e to the power of negative 3 pi out of 4 of I. Just like that.